baseball and live with people. Yeah, we've got a really nice environment. Just get in touch with one of us and you can take a tour anytime. We're pretty good. Take your shoes off, have fun. Right.
Oh, okay. Alright. So, really nice office here, and of course in KL Central, I'm sure it's nice as well. Yeah, so Kuala Lumpur JS, we meet once a month. We used to have workshops, but my co-organizer got really busy with startup, and we now just meet for talks. So this will be our final meetup for the year. Thanks for coming. December, I think I want to take a break. You want to help me out? Yeah, you can organize December's chapter. So what else am I going to say? Okay, yeah, without further ado, I'll invite our first speaker for the night, Richard. So Richard works in the corporate side, and now he's writing books, writing apps, and exploring the life, man. So Richard will be talking about, oh yeah, you can take over. Richard will be talking about how to develop React and Redux apps rapidly. So I'm so interested in the word rapid because I feel like I'm so slow as well. So hopefully you will teach us all a thing or two. So please put your hands together for Richard.
Hello. Can everyone hear me?
Yeah.
Right. Okay. So glad to be here today, especially amongst coders. And I started my coding journey pretty early back when I was studying, but then I went to the corporate, and now I'm out from corporate. I'm still going back into coding because I just love it. Unfortunate thing is that when I went back into coding, I jumped to JavaScript, and I got bloody headache. Really. And that's why I titled it React and Redux. It's a jungle out there, right? The amount of packages and modules and so forth really got me into crazy after a while. But today I'm going to talk a bit about React Redux, just to give you a flavor about how it works. The company that I'm working for uses React Redux extensively. I only started it last year. And to tell you the truth, it took me around 3 to 6 months to figure it all out because no one was there to actually taught me. So I went on like Udemy and Tools class to learn it on my own. Okay? So a little bit about myself. I do technologies and I also do research. And these are the two areas I'll call it my core competencies in life. I love these two areas very much. But in terms of what I write for these two areas, it's really JavaScript, and the other one is English. Right? So the left side is JavaScript, I write applications. The right side will be books. I actually write books for entrepreneurs, startups, and all that kind of stuff. Okay. So what I do at work every day is we're trying to tackle this monster right here. We finished tackling it and we got 1 more month to go. But really this is the home stack. We're actually full stack developers where I come from, and most of us are all trained in full stack development. The thing is that on the front here, I'll just go through very slightly, you guys. We do Node.js and we love Node.js. JavaScript framework to run JavaScript applications on the server side. I'm sure all of you know Node.js. For our web application, because we're developing applications, web applications, we use Express. Okay. And on the one on the upper left is the one that we're interested in today, right? React Redux. Just want to see, anyone here knows React Redux today? Okay, you all code in React Redux. Okay, great. So if I don't know anything, well, if I say something wrong, I do apologize, but I'm still trying to learn. And if I need help, I know who to call. We have middleware, which is an Express middleware that links to the back. Okay. So the back one is a bit tricky because we are connecting to multiple databases, and we cannot just call APIs for each and every single databases. MongoDB, DB2, Oracle. If you're going to code that individually for one of these databases, it's going to be very, very high maintenance, intensive work. Because if let's say we want to add more databases, we need to understand the APIs and code and all that kind of stuff. So we are using loopback. What loopback does is it helps to expose the database from the back as an API, a REST API that we can call easily. So our middleware actually calls APIs, and these APIs will actually interact with the databases behind. Okay. The other thing that we are using loopback for is for authentication. So loopback helps us authenticate our users. And if the users is authenticated successfully, you'll be able to access their data. If loopback does not authenticate that person correctly, loopback will not allow the user to access any data at all. So the authentication is pretty cool. And loopback will actually trigger an error going back to the front end, and we can display it to the users pretty easily. Okay? So this is usually on a high term what we use. And in terms of full stack development, loving it. So we code functions from all the way from the front end to the back end. So we need to know the models of the data store, all the way to the front end UI, which component talks to which, right? And on top of that, I'm not sure whether you all heard it in Silicon Valley today, even in where I work. Full stack developers it's not enough anymore. We need full stack developers who are also designers, who's got taste, who are able to do design thinking and go to the user to ask them exactly what they need. And therefore, we'll be able to envision how to develop a function, a component that goes all the way to the back and all the way to the front. And as a full stack developer, if whatever you code, that function doesn't work, we are able to detach it from the whole application very easily. That's how it works. Any questions so far? Start? Alright, cool. So today we're going to talk a little bit about React Redux. I will not make it too detailed. I prefer like just a high level explanation for everyone. So I think majority of us here don't know React Redux. What do you all think React Redux is? Anyone? Just a shout out. I just want to see what are your perceptions of React Redux? Great. Redux manages state. What about the React part? No? So everybody knows MVC, right? Okay, the model view controller. And the React part is the view part, the V part, right? And I would try and consider the controller, the C, as the Redux side, right, to control. Okay, so let's just go into it. So React, as you know, is a Facebook initiative. And React is used, Facebook is using React extensively, especially on their website. Okay, so at the last I checked today, there's roughly around 30,000 over components built into Facebook today. So the whole web page is filled with components, and they're using React. And so why React? I mean, why did they create React in the first place? In the past, without React, every time there's an update to your DOM, the whole thing has to be rendered again. The whole page has to be rendered again. That's a major problem for high-intensive applications with high features and functionalities. So if you imagine, right, Facebook has got so many components here. If let's say a chat message pops up, in the old days, the whole thing has to be rendered again, and that takes time, right? On top of that, with so many components in the Facebook page today, can you imagine the amount of data management and connectivity that interlinks in between those components is crazy. So we came up with React. And what is React? Simply, just to give you an example, if that same message pops up again, the whole page don't get rendered. It's just that component actually. Right? If your, what do you call that thing in the middle?
The newsfeed.
The newsfeed gets updated with a new message, then only the newsfeed gets updated. Right, so that's React. So we're talking about 30,000 React components today, plus. I mean, that was a post that, like a historical post, I'm not sure, like exactly today how many components are being built. That's a lot. Okay, so I've used it initially and I couldn't grasp the concept. But finally, after a while. So React like if you know in a web page, right, you've got a lot in the web page, every single section is considered a component, it's a web component, right? But in Redux world, there are different kinds of components. And if you go into the forum, there are different kind of names for each component, which will get you even more confused. So I just compile it here for you guys to see. In the React world, there are generally two kinds of component. One is a smart component and the other one is a dumb component. Okay? So a smart component has got state in it. That means it remembers its current state. When a user, for example, clicks open chat box, the chat box being open is a state. So it remembers its state. For a dumb component, it's stateless. That means you're looking at just a visual representation of nothing. It's just visual, right? It's what they call presentational component. It's just visual. No data, anything. You need to feed data in for it to present the data. But its core function is just presenting data, right? And then sometimes they even call it class component. So really, class component is a component that has a state. So, whereas a functional component just does pure function. Whatever you feed it, it just returns out something. Doesn't store any state at all. And last but not least, smart components is containers, and it's also called container component, and the dumb component is called presentational component. That's the concept. So in the whole of the React world, there's a standard to follow by in terms of how we design and build components. The smart component, also known as the parent component, is the one that not only stores state, it's the one that's responsible to pass data, in this case called props, to the child component, in this case dumb component. And it works this way. Right, so the smart component stores states and gets data, that's it. But the ones in the dumb component just presents it. Okay? And it doesn't work the other way around, others React will show an arrow to it. Okay? So now that I've been mentioning a lot of state, so each smart component has state. The next problem arises. What if you got 1,000 components, smart components, and each of it has its own state? And that's where Redux comes in. So Redux kinds of detach each individual's component state and puts it in a store. The global is in memory, and stores all this state in one place, which is a store, for every component to access. It's a global state, and to manage the store, there's a certain way to do it. It's the Redux way. Okay. Is it clear so far? If you all have any questions, just shoot, because I'm just going to go with a general approach to this. So now that we know stores, the Redux store, okay, the ones that are highlighted in solid colors is actually Redux, where you mentioned state, right? Its sole purpose is to gather everybody's state under one store so that everybody can access the state. Okay. On the left side here, bottom left, is the React component that I've been talking about, the smart component, the dumb component. But you see, to update the store, the main state, the component can't just go straight to the store to update it. There's an approach to doing it. First, in order for the React component to update state, they need to fire an action. They call it dispatching an action. So, if let's say you want something to be done in your team, you cannot just go to the person managing the, maybe a better example. Okay, let me just go with a Redux example. If let's say you want to update the store, the React components can go straight to the store, right? So you need to dispatch an action. That action determines which reducer to call, and the reducer is the only one that can update the store. The actions is just like a traffic policeman. So if let's say you got 1,000 dispatch actions being dispatched, the actions, the policeman there will actually trigger the reducers in order. Okay, that's a high level aspect of it. Because the store cannot be updated by multiple people at one time. It's all in linear progression, like one after the other. But it's done very, very fast. The reducer is the only one that can manipulate the store. That means change the state of the store. And the interesting part is that when the store is updated, the components that are referring to the state in the store will get refreshed. Okay? So let's just go with a Facebook chat message again. If let's say someone opens the chat message, there's a trigger of action to say open message, right? In the back end. And the message will dispatch, that action will dispatch an action, and the action will call the reducer to update the state saying that message should open. When that state message opens, it knows that that message, the checkbox component that's referring to that state change, that React component, that particular one gets re-rendered. Right? Is it clear? It's a bit of a big merry-go-round. Any questions, just ask me, because when I explain it, I feel like it's quite complicated, but that's the way it goes. Any question? So I'm yes.
So actions are like a ask message queue kind of thing.
Yeah, you can consider it because it's like the traffic policeman to trigger which reducers to update the state. Right. And within actions, you can do a lot of other functions or checks, or you can call middleware. You can do a lot of things before you call the reducer to update the state. So in our case, if we want to get data from the back end, the database, we'll dispatch an action to say get data from source. So we'll fire an action. That action, that part there, will call our middleware to call the API to get data from the source. And when the data is returned to us, the action will take that data and pump it to the reducer so that the reducer can update the state. When the state is updated with the latest data, React component knows that React component will re-render itself. Only that React component. So, okay? Great. So to grasp it further, I created a demo for you guys to just have a look, because we all speak codes here and we all read codes here. I think it would be much easier for us to see how it works. So there's an if statement here. Do you all want to see the codes?
Yeah, that would be probably good. Yeah, just make sure errors. Okay,
Let me start the server first. Any questions, just shoot, alright? So right now, I'm going to start my Express application server on Node.js.
Microphone.
There are a few comments I can type here, but
Microphone. Richard, mic.
Oh, sorry. Am I good with time?
Yeah.
Awesome, okay. I'm going to start my server right now. So the start dev Mac thing, right, is actually a script. I can rewrite this script anyhow I want. Whether it's to start an Express server or I can... Oh my god. So tiny, huh?
Yeah, that's good.
Anyone here uses, I'm sure a lot of people use Node.js, right?
Not yet.
So these are the modules that I've downloaded run my web application server. Babel is to convert from React scripts or ES5. And you can see out there the scripts. I can create any scripts I want in terms of how I want to execute my JavaScript. And Webpack is the one that bundles everything together into a single file, bundle file, so that when I deploy to production, I just have to deploy that one file, which contains all the packages, all the JavaScripts I need to actually make that application work. So Webpack is bundling the files right now. All my JavaScript putting in one file, a bundle file, collecting all my packages, which is React stuff. It's all done. Server is up and running. So it says here the app is listening on 8082 port. So if I go to my wonderful source page.
One sec, we want to put on the app because
so this is just a simple app that I built. It's actually, oh, where is it? See that application bar on top?
Yeah.
It's actually a working app on Express, and we're utilizing this package called Material UI. So this company is pretty cool. You know Google Material, right? They've got a lot of rules as to how to design an app. So if you're going to design your app and build your app from scratch, the UI, you're going to have to follow those rules, and most of the time, your hair will probably fall off first before you can actually figure it all out. There's so many things in terms of the font size, the color size, and so forth. So this company called Material UI said, heck it, I'm going to predefine all these components up for you up front, following Google Material Standard. So in this case, they say an app bar should be like this height, that's the font size, Roboto, that's where the burger menu is, it's all predefined. I just need to call their component, and everything is all designed beautifully. So it's quite fast for us to create web applications. So imagine this is Facebook web application, and I'm going to open up a chat message. Boop. Ooh, right? So what happens is that drawer that came out on the left, that got rendered. This guys here didn't get rendered at all. So that's React in the making. And what's controlling this, this drawer opening and out is actually Redux. Redux is managing the state of my app right now, saying that the app currently drawer is open, the app currently drawer is closed. And when that state changes, my component reacts to it immediately. Let's look at some codes. This is an example of a smart component. A smart component focuses on the data, getting data from the state or from the source. It doesn't care about presentational layer, and it cares about grabbing data and passing it to the presentational layer. Okay, this is a classic example of a smart component. And how we actually determine a smart component in React world is that, remember, you see this on top, the map state to props and map dispatch to props. These two things are communicating with the Redux store, the state. As you can see here, there's nothing presentational about it. The presentational layer happens here. The application bar and the application drawer is a separate file. This file is your dump component. The function here to dispatch an action is being passed into this dump component. Here, same thing, a function is being passed into a dump component. Here, a prop is being passed into a dump component. So I'll open up the application drawer for you and you'll see how a dump component looks like. Dump component just takes in the data and just displays it accordingly. If the drawer is open, if it's true, this drawer will show. Okay? This is another example of the application bar, that blue part on top. It's also a presentational layer.
Components.
So coming back to the smart component, let's just go into the Redux world. So when I click the burger menu on the right here, what it does is that the application on the application bar, if you do it here, it says here, it shows up a function open drawer. Okay? See the open drawer here? This map dispatch to procs is the exit point in the component to call an action to update state in Redux store. So if I click open drawer, this function will call, it will dispatch an action. The action is open drawer. If I go to my action file, it will detect open drawer and set the type to open drawer. I can name this anyhow I want, but the reducer needs this type name in order to know what to do next. So if it's open drawer or in caps, if you look at my reducer, it goes through a switch statement, open drawer. If that action has been called, my reducer will set the state to true. And when the state gets set to true, the drawer will pop up. So I'll give you a demo on how it looks like in the console.log. So in the console.log, I don't have to print out the state information in the console. There's actually a plugin for Chrome, a Redux plugin. It's quite beautiful here. You can see here my state here in memory. The drawer state is stored false. When I click this burger menu, it's going to change the state to true. Goes to true, this React component reacts to it. One whole cycle. Okay? So that's the demo or the gist of React Redux. If you have any questions? Yeah. Wow, that would be, I don't think I have the time to actually explain that, but it's a good question. Generally, if let's say that you want information in the drawer, it's saying over there, I would say that for this particular component, in this component it requires data, right, to fill up, right? So I would tell my parent component to say, get some data from the source, right? So they will have to dispatch another action which you have to code. That will call an API at the back to pull the data. And when the data comes back, the action will pass the data to the reducer and tell the reducer, please update the data at the state. Then this particular component knows that, oh, there's new data in the state. Therefore, in my component, I'll say, if data exists, display data in this component. Right? Yeah. So if everyone goes in that circle. And in terms of development work, there's a huge amount of team. Everyone talks the same state, everyone agrees with the same state, but they can build multiple components that won't affect each other. Because each component has their own demands as to what data they want, or they have demands as to what kind of actions they want to dispatch. And if the component is crap, the user doesn't like it, we can remove that component, and we can remove all the actions that he has built and all the reducers that he has, provided it's not shared. So, any questions? Yes. We're using Express middleware. Express. And in the middleware, we use promises. So in terms of promises, what if, for example, the problem happens when you call a database for data and the database takes too long, there's a timeout. The promises actually handles that. So in the promises, you can say that data took too long, then show an error to the file, or call another action or whatnot. But the middleware is what we use to actually keep track on the communication between back-end and front-end. We use Express middleware.
Final question?
Yes.
If you want to build some application which is not so dictated, can we just use React to build it without Redux?
Yes, you can. You can. It's just that for each React component, you will be managing your own state. Yeah. The people that I spoke to, when they do React, it's as though React and Redux complement each other and usually use it together. So, to tell you the truth, I've not spoken to enough people to know that it's okay just to code with React. But usually the people that I meet always has Redux in play, because it's easier to manage that way. Yeah. So this, so online, I realized when there's a lot of tutorials or a lot of videos on how to code in React, they always have Redux in it. They always have React router in it. They always have Express in it. It's like they always package these two things together, and that's how the community is going. But I have not personally coded just purely in React. Like when I started, my architect says, we've got to do this together with React Redux, and I went on with React Redux all the way. Oh, question. Sorry? Never use Mopax. I haven't tried it. And the other one is Flux, is it? I haven't used it. Yeah. So, in my case, I was taught early on that the syntax and the packages doesn't really matter because there's just too many of it. As long as you can understand concepts, it's enough already. And syntax is just one of those things. Right. So every day I hear new technologies, especially from the Upstack guys. Like today they blew me away with the tools they use, and next week I'll be getting another whole bunch of tools. It will never end. It's crazy out there. It's a jungle. I never thought I would be going to this world, but eventually I did for a while. But a common language which I'm kind of happy that all of us speak JavaScript. That's the true part. Yeah.
One of the things Redux was pushed for was that you can play back each and every section and run through a debug.
Oh yeah.
Is that managed by Redux itself, or do you have to manage that stack, that historical stack as well?
I don't manage it at all.
So Redux has something built in.
Yeah. You realize just now my Chrome browser, I've got a plugin at the side. The browser alone goes through all the historical actions, and I can see it, what happened in the past. The only time when those historical things disappear is when you reload the page. You call the server again, and then it clears the memory, then you don't have it anymore.
So Redux handles that stack?
Yeah. I would take it. Is Redux, because I saw it with the historical actions that I made.
That's one of the things about Redux, that you're recording every single action.
Yeah.
If you want to debug what the user does, you just replay back what they've done.
Right. That's pretty cool. Yeah, I like that. Okay. I'm so sorry. Good timing.
Yeah, great. That's nice. Thanks.
I do want to point out Redux you can actually use with your favorite framework, but I think the plugin won't work as nice as that plugin there in Chrome. Personally, I'm using Polymer with Redux, so I'm a bit of a hipster, I'm sorry. The reason why Polymer is because it's more browser standard. React is Facebook standard. and it probably won't make it to the browser, but we'll see. I don't know, we'll see. And my app is not that complicated. But Redux is definitely, I really endorse Redux. You should use it if your app, no matter how simple your app is, because there's no such thing as a simple single-page application anymore, in my opinion. All right. Okay, just to move on, I'll be speaking a bit about service workers. So, what's service workers? Definition right out of Google developers. A script that runs in the background, separate from your DOM page, that opens a bunch of features that don't need, well, that unlocks features that don't need web page or user interaction. Or a better definition by MDN, Mozilla, documentation is they are actually proxy servers that sit between your web apps and the browser and the network. So you'll see a picture of that soon. Okay, so service workers is actually can be a very big topic. You can actually do a lot of things with it. And I think Lai will come up later and talk about some of the things that other service worker groups can do. But today I'm going to highlight on how service workers can help you bring offline experiences to your application. Because for the longest time, web apps they are live and you're online, and they're kind of dead when you're offline. So service workers are here to fill that gap for us because they allow the ability to intercept and handle network requests. So they sit between your app and the network, which is a very powerful, very powerful thing. So essentially, with that proxy in between your app and the network, you can use the service worker to cache files and to cache your API. And so even if you go offline, the user can actually use your app, even if they hit reload, which is really powerful, right? And then you can update later when you go online, etc., etc. Okay, some notes about the service worker. Service workers, they don't live in the DOM JavaScript thread, they live in a background thread, so they can't access the DOM directly. If you want to talk between your service worker and your main JavaScript thread, you have to use post message, which works quite decently. So essentially what I said just now, service worker is really a programmable network proxy, which is really powerful. They also get terminated when they are not used, and they are restarted when needed. So there's a life cycle, more or less like a mobile app development. You have to follow the service worker life cycle rules. And because the service worker script can be terminated at will whenever the browser wants to terminate it, you can't keep any global state in your service worker script. And if you want to keep some global state, you've got to use either some local storage, or there's this thing called IndexedDB, which I'm quite interested in, where you can store big amounts of files and state. But that's for another talk, IndexedDB. To use service worker, also you need to know promises, because, well, actually today, if you want to build anything in JavaScript, you need to know promises. So please do brush up on your promises before trying to understand service workers. So this is the service worker lifecycle. Initially, there's no service worker when the user loads the page for the first time. No service worker. And then browser detects, oh, there is a service worker. Let me try to install it. And when it tries to install the service worker, it either goes to error state. It says, I can't install it because of reasons which I will talk about later. Or we can go to activated state, which means, okay, service worker is in control, and we can now, it sits right between the app and the network. But also we can go to idle and it goes to terminated, or it goes to idle and it's actively being used to fetch network requests. So this is the life cycle of a service worker. Okay, before diving deeper, is it here yet? Yes and no. Good news is the biggest two browsers in the world, which probably hold 80% browser market share, is already supporting Service Worker. So you can definitely use it today. And Safari and Edge is now in development. So it's definitely a thing, definitely standards-based. Your code is safe, okay? You don't have to rewrite stuff. Okay, so because the Service Worker is so powerful, it sits between your app and the network, you must use HTTPS in production, no questions. Because that, otherwise you are susceptible to man-in-the-middle attacks. But localhost is permitted for local development, right? Yeah, it's very powerful stuff, so don't play. Okay, first in the step is registering the Service Worker. So you have a script, sw.js, that is your Service Worker script. So how do you tell the browser to install it if supported? So if it's supported, check for Service Worker property in Navigator. And on the page load, register using this API. Give it a path to the Service Worker. And then basically this is a promise on the success callback and the error callback. Alright. So you can register as many times as you like. It doesn't matter. The browser will figure out if it already has activated the Service Worker or not. Okay? And this is the thing, right? You see that this Service Worker here sits in the root path, which means that it can actually act as the proxy for all the paths in your website. But if your Service Worker is registered like this, /example/Service Worker, which means that the Service Worker will only take effect for that path, example/example. And your root path will not be affected by the Service Worker. So it's really powerful stuff. You can have different Service Workers guarding different stuff. So I call it path guardians, alright? Just remember that the scope of the Service Worker depends on the path where you put the Service Worker at. Okay, so a bit of a debugging help here. So Chrome /inspect will give you, it's basically the debugging tool will display all the Service Workers that are currently active in your browser right now. There's also another URL where you can get even more detail about Service Workers. Yeah, so do check it out. And another testing tip, sorry this is kind of all over the place, it's kind of like plucked from the article. Yeah, if you test your Service Workers in the Chrome incognito window, you can close and reopen it knowing that the previous Service Worker won't affect the new window. This is because in the normal browser window, your Service Workers will be persistent. Even if you close the window, it will still be alive in the background. So if you want to test quickly, then you can use incognito window because it will reinstall itself fresh every time you open a new incognito window. But that's Chrome. Okay. So we have registered, right? Just now we told the browser, okay, Navigator, Service Worker.register. Then in your Service Worker script, so this is the first event you need to care about, install. So the browser will say, okay, I've loaded you. I'm going to call install on you. And now you're going to do this callback, all right? And in this example, we will be doing these three things. We will open and create a cache. We will tell the cache, okay, these are the files you need to cache. And then you need to confirm that all required files given to it are cached. Or cached, I don't know what I like cache. Okay, so within this callback, let's see some code to put in there. Alright, first of all, we have a cache name. Alright, give it a version number and prefix it with your site name. Okay. There are reasons why you do it. Okay, you need to give in a whitelist of all the URLs that you want cached. Okay, so on service self-add event listener install, on the install callback, first of all, there's this weird API. Okay, it's called event wait until. It basically takes a promise and uses the promise to know how long the installation took and whether it succeeded or not. Okay, so I'm really new to all this as well. Just follow event wait until, because caches.open presumably gives a promise that rejects or fail or passes depending on whether the cache succeeded. Okay. So here, okay, let's move on to the next one. So caches.open will basically just open the cache with the name given. And that should succeed, right? And then you proceed to add all the URLs that you listed at the top, the whitelist. Okay. So here's the gotcha. If any of these URLs fail to load, so the cache will proceed to try to load all this in the network. If any of these listed files fail to download, you had a typo, or the files one of the files is actually a 404, the whole install step will fail and your service worker will go to error state. All or nothing. So this gives you the confidence that when it actually succeeds, all the assets that you define there are really there. They're cached. They're not like, oh, it's half there and half there. It's all there. So this is the gotcha. Install step needs to take an array of all the URLs, and then it will try to download everything, and if it fails, it will just fail to install. Alright? So after installing, what's next? If install succeeded, it means that the browser will call the service worker again with the activate event. Okay? When you have the activate event, means install succeeded. But even though the activate event is being called, it doesn't mean that the service worker is in control of the current page. Alright, imagine with me that the user is brand new, alright, Hacker News, he landed on your service worker website. When he lands on the service worker website, or your website, browser detect service worker, browser install service worker, activate. But the service worker is not yet in the place of control. Then only will your service worker be activated and in control. So basically, if the page loaded without service worker, everything else that comes after that will be loaded without service worker. Even though the service worker actually activated. It's only when the user refreshes the page, then everything will go through the service worker. Alright? So if you don't like that, you can actually, there's actually a method you can call, it's called clients.claim, where we'll see that later, which means, okay, if I'm activated, I don't care if the page loaded with or without me, I want to control right now. But there's a reason why that is not the default, right? Because all this state management stuff gets really messy. So we'll look into that. But there's an option if you want your service worker to get control right now. But usually you don't need to do this, right? You should not. Yeah, I mean, you don't have to, according to the Google expert who wrote the article, you don't have to take control now, right? Because if the page is working with the network, it should work with the network. It shouldn't depend on the service worker. Okay, so now you have installed, you have activated, then now you can use the service worker once it's in control. It will get the fetch event, and then in the fetch callback, you will try to match the event request to the cache, and if you get a response, return it. If not, let's go and query the internet. Okay, but this in itself does not actually put the result back in the cache. So it does not dynamically update your cache. Okay? So if matching response found, return it. If not, make a network request. To actually put the result of the network request back in the cache, we need to do more work. And this is the more work. Feel like missing some slides. Okay. Let's look up here, right? If cache hit, return. If not, we got to clone the request. I'm missing some slides. Okay. The reason why we need to clone the request is basically the request is like a stream, and once you read from it, there's nothing to read from anymore. So you need to clone it, and then use that to actually do a fetch. I'm sorry, I'm thinking. And once you fetch using the clone request, there's this thing in the sample code that checks if it's a basic response type or not. If it's not basic, it means that the request is coming from some other origin. Okay, we're getting a bit too much detail here. Never mind this. Using the clone request fetch, and then you need to clone the response. Because the response is again another thing where you read from it once and you can't read from it anymore. This is the stream. Clone the response and open the cache and put the original request with the clone response into the cache. All this code is on the, I'll put it up. It's not from me anyway, it's from the Google developer site. So just bear in mind to take away, if you want to actually dynamically update your cache, you need to clone the request, you need to clone the response, which is the way things are happening now. Okay? Okay, response is a stream, it can only be consumed once, we need to clone it, so we have two streams. So you clone the response stream and you set it to the cache, and the original you give it back to the user for immediate consumption. Alright. Okay, so that's all good. We have installed it. Okay, register, install, activate, fetch. Okay, and now, okay, you deploy it in production, you're so happy with it, and later you need to update some functionality. You need to edit your service worker. So, update the service worker script file, and the browser will try to re-download the service worker file. If it sees as much as a space, an additional space in your file that's different, it will try to reinstall the whole service worker. Okay, and the advice is to keep the service worker. Don't name your service worker files with versions, because it gets a bit hairy. Okay, just keep you can update your service worker file, just keep it at the same path name. You don't have to put version. There's a reason for it, because you can get really messy. Because if you rename your service worker file, the browser detects it, it will install that one. And your old one, the browser doesn't actually know that you're taking over the old one. Now you have two service workers running. So yeah, there's a lot of things to be careful here. You gotta, I think there's a lot of pitfalls in service workers, so please be careful. And it will go through the whole cycle again, install. So now the old service worker is in control, and the new service worker enters the waiting state. Again, it doesn't take control immediately. Only when you close the page, then the browser will kill the service worker, the old one, and put the new one in there. And then fire activate. Okay? Okay, this is, maybe I'll try to, okay. Okay, so in the activate callback, normally what you want to do is change what you're caching. Okay, so in the new service worker file, in the activate callback, you may want to clear some old stuff. Okay, you don't want to do this in the install callback because the old service worker is still using the old cache. So there's a lot of things to remember. So this is how to do it. You should do a whitelist of the caches that you care about right now, right? Whitelist, and then in the activate callback, you have to go through all the cache keys, and if it doesn't match your whitelist, just throw it away. Why? Because your new service worker may not be the most, okay, let's say the new service worker is version N, alright? The service worker you're taking over may not be version N-1, it may be N-10. So all you care about is this now, so you should use the whitelist and throw away everything else, okay? Delete the old one. So here's a nice video. Install the service worker. It's a bit fast. Let's try again. Okay, installing. Once it's active, reload the browser. You saw it reloading. And then only everything from the browser network request will go through the service worker. Reload first, and then everything goes through the service worker. So this is the installing phase. And you can use the clients.claim API to take control without page refresh, but not recommended. Okay, this is how to update the service worker. You install it, it goes into waiting phase while the active one is still active. Kill the page, active one goes away, waiting one goes into active. Alright, so we talked about that. Okay, yeah, this is the one I wanted to show you. Okay, now this one. So if you don't want your new service worker to be stuck in waiting, you can use skip waiting in the install callback, and the browser will kick out the current one. Okay, so these are the two overrides: the client claims and self-skip waiting. Okay, here's some dev tips. Update on reload checkbox here in your console to basically install and activate the service worker immediately. You can click on the skip waiting button here. Once you have a new service worker and is waiting in line, just click on that to activate. And apparently if you use shift reload, command shift R, it will bypass service worker entirely. And apparently this is in the spec. Okay, so let's see a demo app. Again, not by me, by Jake, one of the developer advocates. Okay, this is kind of a cheat, I guess I've loaded this already. Okay, so this website has a service worker in the background, and let's try to go offline. Go offline and display myself at the side. Okay, so now I am going to do Command R, and basically everything here is loaded offline, so your application still works offline, and your user is happy because they can now read and use your app on the train or airport or on the plane. And let's just take a look at the service worker code for that same application, because it's everything we just talked about. Okay. There's the cache name, the version name for, presumably version name for this service worker. This is the cache name. So on the install event, he doesn't want to wait, he skips waiting. And he opens the cache, and he fills it up with all the stuff that he wants cached up front. Okay, these are all the static JavaScript, CSS, images stuff. This is the whitelist of all the caches that he expects to have. On the activate callback, again, he doesn't want to wait. He wants it to claim immediately, claim control. And then he goes through all the cache keys and the cache and deletes them from the cache if it's not in the expected list of caches, right? And then on the fetch, does some fancy stuff. If it's from API Flickr, call this. If it's some static one, call that. So actually, let's look at the static one. It's much easier to see. If the cache matches the request, then just return it. Otherwise, go and fetch it and put the response in the cache and return the clone response. So in this case, he didn't clone the request, and I wonder why. But just bear in mind, we might need to do that. In the API, see, even caches API, the JSON, is doing some really fancy thing. I don't even know what it's doing. Basically, it's caching the API. So everything that we just talked about today in one file. So actually, I'm really excited about this. I'm developing page-dash.com, which is I call it the scrapbook for the web. So this is my dashboard. Let's say, Hacker News. I want to save it, so I'll just save by clicking on the extension button. So I'm not promoting myself, by the way. I'm just demoing. Okay, and now this website is completely cloned from the original. If Hacker News goes down tomorrow, I can still read it. Okay, so this is exciting for me because I can use service workers to actually cache all the static files for each website. Because everyone's telling me, why no offline mode? So this is the potential use case. This is definitely possible with everything we talked about today. And the other thing I'm really excited about is, the extension part, because right now it's sending files to the server. And that's kind of slow. So I'm hoping that Service Worker could help me act as a queue to slowly push stuff out. But that's kind of not in the tutorial. So I need to figure it out. So that's my use case for real-world application for Service Worker. Well, there's a lot of things you can do with it. Background data syncing, centralized updates, really advanced stuff. So I would just recommend you get the hands dirty first. Browser compatibility, as we said, not so much here yet, except for Chrome and Firefox, but Safari and Edge are coming soon. Yep, that's reference. Okay, that's it. Time for one question. One question, anyone?
Is this one Chrome eats on my memory?
Okay, that's it. Next, we have one more talk. Please invite to the stage Lai. Lai is currently freelancing. He's working and he's also looking for gigs, right? Job, gigs, maybe. All right. Well, he sounds like a really talented guy. So if you wanna need help with your app, you can look for him.
Okay. Evening, everybody. I'm Lai. You call me Johnson if you want. So just a quick introduction about myself. Actually, I created this slide. It should be like for my Mac, so it doesn't show fully flip. And this is my GitHub profile. So I just give you guys a brief introduction about myself. I'm actually a full-stack web developer at Mark. So my company is a real-time bidding website. So we're dealing with like dealers bidding cars. So we need to create some apps that a web application that has a lot of modern stuff like WebSocket. So I just talk about my experience with progressive web app. So first, I created my first progressive web app a month ago. It's called Util. So this is the Google Lighthouse score that I get, I think 100, but it uses an offline plugin. So I contributed to an open source project called OpenDota. Anyone heard of it? It's an open source project, so I added the add to home screen, the functionality to the website for the Hacktoberfest event. Okay, so now I'm trying to convince my boss to use this thing in production. So what I do at my job basically is this is one of the bidding. So I made 9 browsers just to test the real-time bidding, see whether it will crash or not, something like that. Okay. So first, just to make everyone in the same page, so I want to give just what is progressive web app. So when I explain progressive web app, all those features that provided by progressive web app to my friends, so they ask me again, is this something like Cordova or what's it the other one? PhoneGap? Yeah. So I said no. It's basically progressive web app is something different. It's not that we want to create a native app. So we want to make our web more approachable to mobile user. So this is a definition given by Wikipedia. It's a term used to denote web applications that use the latest web technologies, but it's a bit abstract about the latest web technologies because everyone don't know what's the latest one. So from Ionic framework is I think it's more readable in the sense that it says that it delivers an app-like experience to users. For my definition, I describe it a bit different. So I like to say that progressive web app is adding a couple of modern web features into any of your existing web app. Meaning that for today onwards, you can add it into any of your existing website to use all those very latest web technologies. Okay, so just a warning is that everything is experimental here. Although some of it you use it in production, you won't break the website, but just a heads up. If you read through all the MDN Mozilla Available Network, all those things everything is stated there with this line, experimental technology. Okay, so browser support. So the browser support only works on Chrome and Firefox and Android for most of the features. So for iPhone users, it could be a bad. So if you don't have support for iPhone. So first I'm going to talk about add to home screen. Add to home screen is something very interesting that only works on Chrome and Android. So this is I think I can make I made a demo of it. So this is a website I created. Is it so small? Okay, so this so there's a function called add to home screen. So by pressing this button, it doesn't work. I think I added to home screen before. Okay, it doesn't work. Maybe you guys can try it. Sometimes it works, sometimes it doesn't work because it's something very cutting edge because it only supports in Chrome. So I talk about the requirement. So first you need to have your HTTPS, service worker, and manifest JSON. So this is basically you need a service worker registered. So in manifest JSON, so this is just like creating any iOS app. You need to state that how big is your image. So in iOS development, in Xcode, it's basically drag and drop. But in ours, for our web, we need to create a JSON file. So this is a sample of the JSON file. Okay. So first, you need to state the name of your app, and then the short name, the theme color, the background color. Then I think everything is self-explanatory. Just the icons part. You need to state that where's the source of it, the size, the image, is it PNG or JPEG. So what's the result of it is that when the user uses the website, you can see that at my home, you can see that it's a green color here. You see it's matching to my nav bar color. So I'm using also materialized CSS, so it's the same as the previous the speakers talk about this. Okay. So this only supports in manifest.json only support in Opera, Chrome, Firefox, and Android phone. So even though those it doesn't have add to home screen, but you still can have all those features like this green color bar that match to your nav bar. So for iOS, you still have these features, but you need to add it manually for iOS. So I think everyone is familiar with iPhone that you have this add to home screen, then you show up as this. So this is just a fallback strategy for that. So in iOS, so we need to, in the HTML file, we need to create a metadata. So to state that, for the iOS, we need to state that the name of your app is Phytomark, and the content is black, and you have a source of your image. But this one, not just 72 times 72, you need to add a few of it. Okay, so I just talk about the add to home screen first. So the browser support right now for add to home screen that will just prompt up from your phone is only supported in Android. As you can see, it's Firefox and Android and Chrome for Android. So for iOS, there's no this kind of thing, but you still can have fallback for those who want to use this. So this from the NDA website is stated that this add to home screen features is non-standard. So this is an event called before install prompt event. So this is the event. You can add a window event listener into this so that you can trigger the button as I stated just now. This is a button that add to home screen. So okay, I think I know what's the reason, because I think I written some error in my service worker. Okay, just give me a second. See, there's a add to home screen pop-up. You see that? But this one I didn't click it. So this when I don't click it, it will pop up. Is another thing from the Google Developer website. It stated that there's a certain benchmark for me to for you to prompt up this from Google Chrome. Is that when you need to serve this website for a few times and a certain limit of time. So I think it's the previously it stated that 5 minutes each visit for twice. So you need to visit this website for twice and each time is 5 minutes. This is a previous requirement, but it changes over time. So everything I included in the slides is that is here, the reference here. So according to Google website, it stated that the minimum requirement for this event. So you can see in this is that when you serve to that website, you prompt up this add to home screen. So in this case, the criteria is you have a minimum the minimum requirement is to have a manifest.json file as a short name and a PNG file and a start URL. The start URL, when you click on the app, you go to that URL, and service worker must register and HTTPS as required by the service worker. And this line is a bit abstract. So it meets the site engagement heuristic defined by Google Chrome. So this is very abstract because there's not a real, it changed every time. So 2 months ago, it was stated that 5 minutes each visit, and you need to visit this site for twice. And if you want to manually prompt up that button, you need to create an event. So the event is called before install prompt event. It only support in Chrome, so you can manually prompt up that thing. But I won't suggest you guys using this in production because it only works in Chrome, and as you can see, it doesn't work just now. So it's experimental. So this is the code for it. So first, we need to add an event listener to before install prompt. If this event exists, then you can just save the event value into the default prompt. Okay, then you just return false to close out the event listener, and then in the button, when the button is clicked, just now that button click, so you can just prompt up using a default prompt. So you will just prompt up from the screen. It's just like that. So I have two choices right now. Is either add to home screen or I just close it. So if the user add to home screen, you can do something. So you can see that from the user choice here, then you can use a function. It's a promise. Then you can just use the user choice result, and you can, if the user dismiss, then you will console log that, and if you add the home screen, then you just console log that. You can do whatever you want in here. This is inside the. Then you need to remove those buttons. So you can do anything like alert or all kinds of typical JavaScript DOM stuff. So next I'm going to talk about push notification. So push notification is combines of two API. So it's push API and notification API. So today I'm going to mainly talk about notification API and just a demo about push API. Just a note that this push and notification API, it works on Chrome, Firefox, and all those Opera and Android, but it doesn't work on iPhone because iPhone runs a different thing. So it's called Safari push notification. I did not take a look in it because I don't have much time to research on Safari push notification. But I think they use the same concept of push notification, just that you need to change your code just to send to a Safari user. So this is how a typical web app looks like with a service worker registered. So our typical JavaScript DOM is on a single thread, and the service worker lives in another thread. So we can abuse this even though this website is closed. So even this website is closed, the service worker is still running in the background. So this is a big picture view on how push notification works. So we use a Chrome server. There's a certain URL for that, and then you just use a push event in the service worker, and you can just deliver into a web app. So basically you can use two servers for this event. So this is your main server with your SQL as a backend or whatsoever, and then you can send it to the other cloud server just for the pushing. So I tried to use Firebase for the just push notification, but it's quite complicated. I think I managed to make it work after like I think a few attempts. So I'm going to talk about notification API. So the notification API. So you need to have users accept your notification request. So this is, for example, just add the home screen first. So add it. So this is a push notification. So I need to enable the notification. So when I press this button, the users need to allow it. If the user doesn't allow it, so you cannot send a push notification. So it requires users to press this allow button. So this allow button will just subscribe the users to it. So you can see I received a notification here because I created it manually. So just a start of it. Okay. So we create an event listener on the button. So if the user press that button, so So this basically is if the notification supported by the browser, so you'll just show out the button. So this is the function that called by the button click. So you just request the permission, and then if the permission is not granted, you cannot use the notification API. So if the permission is granted, you can use the permission, the notification API, and then you run a function called a sample notification. This one just to make a sample notification for me to demo out about the notification API. So the sample notification is normally you will check service worker whether is registered. If it's registered, we can use all these features. So first is the body. So the body of the text is something like this. So I'm not sure whether you can show you. Okay, so so the body is the successful subscribe to PWM example website. So this is the body. So the image, the icon is basically this. Okay, it's this icon. Okay, and then there's an image you can edit to show on the. But for some reason it's not working. Okay, never mind. Then you can state the language, the vibration. So vibration is when your phone has support the vibration, so you can give out the notification in a vibration method. Is 200 millisecond, 10 millisecond of stop, start, stop, and start. Next is the beige. Beige basically is something that shown in here. You see that white square? So basically it's the logo of this. So you can make any like a dolphin or whatsoever you want. And then next is we can we stack the notification, meaning that can we spam the user like a lot of notification to them. So this is a re-notify. So the actions, you can add actions to it. So basically the users can have it doesn't support here. I'll show it on my browser. So on my browser, when I click it, okay, I don't know why it doesn't work. I think maybe I need to. Oh yeah, it works, but it didn't prompt out. Oh, I know why. Because I think it's different screen, so maybe it doesn't work. So basically, you see that I receive a
push notification.
yeah.
Push notification. You just enable that.
Oh, I turn it. Is it? Oh, wait, where? Oh, okay. Okay, my bad. Okay, yeah, you see it works.
Yes.
So you can make an OK and cancel. Where is it? Okay, you can make an OK or cancel, and then normally you can add a link at here, but I didn't add it. So this is when the service worker is ready. So you create a variable called notification content, and you pass it into the. So when the service worker is ready, you add a promise to it when it's ready. Then you just pass the show notification. So this is the header of the notification. As you can see, the header of notification is here, subscribe. And then the content, if the service worker doesn't exist, you still can use this, but you cannot use the push API for this. Okay. Next. So for this ask for permission, is support in all Androids and Opera, Firefox, and Chrome, everything as I stated previously, but it's not supported in Safari. Safari they uses a different way. So now I'm gonna demo a push API, how it works, since we are running out of time. So I just make a demo on push API. I think I started. Yeah, I started it. So I subscribe to it. So first, the user need to subscribe to the push notification first. So basically, I run a curl function. Basically, I run a curl function just to send this. So this authenticate secret, just to send, because we need to be authenticate user to send a push notification. So I send a title of KLJS and hey everyone, and this click target basically just will show up the link to it. So, okay, so I just run this shell script. You see, I receive a message here. So it's KLJS, hey everyone, and there's a sponge bar there. Okay, so this is a push, sending a push API. So you can do it, but I think I did add a setting. So if I close it, so I can send it again. Okay, because I subscribe to it, because I subscribe to the event. Okay, so I think that's the main part of everything. So I'm gonna talk about others. The other thing, maybe you can use it.
Basic messaging.
So one of the cool things is that there's a weird form I created. Basically, you can use a vibrate, but it doesn't work on desktop, so you can try it on your phone. So the link is at my GitHub. It's up here. So if you guys have phone, you can go and try this out. So at this website, you can use a vibration and all those kind of stuff. So this is this also support the gyroscope on your phone. As you can see, I even works on desktop. I just know. You can try all this in creating a games or something. So next is camera. You can also use camera. I think I make a sticker of it. Okay. So I placed a sticker here, so you can only see it as a black and white. Okay, so you can unmute it. Basically, you can record sound or something. You can do anything you like, because this is all those latest technologies you can use. And lastly, there are a few more coming soon to the Progressive Web app, or it already exists, but it's not a good browser support. So these are the three things that I'm I'm quite interested in is both of these payment requests and online offline events. Online and offline events, I actually use it in production because we are doing a real-time bidding. So when the user is offline, we will prompt up that telling that you are offline, you cannot bid the card. So we actually use this in production. And payment request API is something very interesting created by, it only works on Google Chrome right now. So this one is basically you can make payment on web. You can make payment on web. So you see that it's just prompt up here, and you can make payments with Google Pay or credit cards and all kinds of things. So it supports on mobile. So it could be the future that you can add a payment gateway in this way instead of PayPal or all kinds of other stuff. Next is the ambient light event. This only support on Mozilla. So basically you can create a better user reading features by knowing that the users are at a very light event or not in a dark room or something like that. So this event basically use as the same as a window at event listener. Okay, so that's all for my talk today. So any question and answer? Now it's question and answering. So any question?
So is iOS 4 planned?
Pardon?
Is iOS 4 planned? iPhone support.
I cannot hear you.
When iPhone support?
Oh, okay. I'm sorry. So iPhone support. First, you need to know when service worker will support. So I'll show you guys so normally I will use. Can I use website? So in service worker, so service worker wasn't supported on iOS at all. Even the latest one, and I don't think they want to support service worker anytime right now. Maybe in the future, 2 years or 3 years.
What are we to do?
Although all this stuff I use a notification API or add home screen, even you add to your web, it doesn't hurt your other user like iOS. They just don't show it. That's all. They don't read it. Just like they don't understand what service worker. Okay. Any question? Sorry.
Any ways to do notification besides Firebase? Is it the best
Yeah.
the way to do?
Okay. For push notification, first there's like in the past it's very hard to do because I think only Firebase supports. It's called Firebase Cloud Messaging, FCM. But for me, I'm using a Node app, Node.js app. So basically, I need to set up the key first. I'm sorry.
The demo just now you show the.
Yeah.
That part is a Node.js app.
Not necessarily just Node. I mean, yeah, because I can where is it? So basically, I just send a post request. Yeah. So you see that I send it to the notify all endpoint. So at this endpoint, I send a authenticate. This is my password. So I send a title, a message, and a click target into the click target. When you press it, it will just go to that link. So when you press it, it will just go to that link. So how to create this? First, you need to create a private and public key for both users. So I'll show you guys a code first. Okay, so in this is called config push subscription. So in here, okay, so basically you need to give a public key. So this is a public key. So but you need to convert your public key into UINT 8 array because you cannot send this data out. and then you create a subscription. This is on the Firebase. This wasn't just on the app, but this one is the way I did it. Okay, so basically you send a fetch request to your browser. So in Firebase, so you have a subscription. So in Firebase, you see that the subscription there's an endpoint. This endpoint is the way you should push. You should send the JSON. I think it's JSON to it. So and then this is the authenticate code and the P256DH. So this is just added to your database so that you can send the push notification to that certain person. So you can create a group, like for example, those who are from KL, those who are from Selangor, you can send push notification just to KL people. Yeah, something like that. It's a bit hard to explain because I'm not very good at back-end development. So I'm also quite new to this push API. I think I tried 2 weeks ago on this. So I use Firebase for doing this, but it gets a bit weird sometimes. It doesn't work. So I tried on the Node app. It works mostly. Okay. And anything else? Thank you guys.
Okay, I really want to thank the speakers tonight because I didn't do anything to find them. They found me, they messaged me, hey, I want to give a talk. Or they just sign up on the forum. So I really want to encourage you guys. You know, the web there's so much experimental stuff, and I'm sure in all your brains you have a lot of experience. Please share it with us. It doesn't take much because I didn't know anything about service workers before lunch today. Just started after lunch. So pick your topic. There's so many topics. I can't even finish, listing them. Pick one and sign up and give a talk. I think we'll meet next in January. If not January, maybe after Chinese New Year. If you're lazy, depends on how lazy you feel. Okay. Thanks everyone. Please do have a good holiday season and
Merry Christmas.
keep coding. All right. Good night.